Hey guys, so in today's lecture, we are going to discuss performance of wind energy conversion system and development of wind energy in India. So, two topics we are going to discuss. So, first is performance of wind energy system conversion system. So, in performance of wind energy conversion system, so, how we will calculate the performance? So, performance can be calculated by the efficiency of each and every component of the whole wind energy conversion system. That is WCS system. So, various parts which we have seen in the wind energy conversion system. So, all this efficiency will be multiplied and we will get an overall efficiency, that is eta O, that is the efficiency of wind energy conversion system. So what are the parts? So in WECS the parts were turbine, then gearing, then coupling, and then generator. So there are four parts, and controller also, but mainly four parts. So all the efficiencies will be multiplied. That is efficiency of turbine, then efficiency of gearing, then efficiency of coupling, and efficiency of generator. So we will multiply all this and overall efficiency will be found out. So the efficiency of wind turbine is the lowest in the wind energy conversion system. That is, this efficiency is the lowest, and the efficiency of the remaining element are quite high, and the remaining element are greater than 90% but less than 100%. So the efficiency of the wind turbine, that is efficiency of wind turbine eta A, is equal to, so efficiency is generally defined as output upon input. So what is here output and what is our input? So our output is the shaft power. So shaft power is the output, and what is the input? So input is wind power. So wind power is the input. So the ratio of shaft power upon wind power is our efficiency of the turbine. So the maximum efficiency that can be achieved, let's say it is Cp, so that is power coefficient Cp. So maximum efficiency that can be achieved. So power coefficient is defined as maximum fraction of the power in the wind stream that can be extracted. So that is Cp. So according to the Betz, we have a limit, that is theoretical maximum value is 0.593. That is Betz limit. We have seen in this theory that Betz limit is 0.593 on wind energy conversion system. So the Carnot efficiency is limitation on conventional thermal power plant. So similarly, here the Betz limit is the limitation for the wind energy conversion system, that is 59.3%. So now we will see the variation of power coefficient with tip speed ratio. So here on the x-axis we have tip speed ratio, and on the y-axis we have power coefficient. So the best criterion here, the maximum power coefficient can go up to 59.3%. So here we have limited up to 59.3 percentage. And here on the x-axis we have tip speed ratio lambda. Now what is tip speed ratio? If you remember, the tip speed ratio is the ratio of outer wind speed, outer blade speed divided by wind speed, free stream of wind. That is the tip speed ratio. So if here we can see that in this graph, the graph is plotted for horizontal and vertical axis rotors. So as you can see that here there are vertical rotors and also horizontal rotors. So here we can see that the highest value of power coefficient is achieved by two bladed or three bladed with propeller type rotors. So propeller type, two bladed or three bladed rotors. So you have seen that four blade rotor is not having much higher efficiency, means much higher power coefficient. So the American, as you can see, the American multi blade, so many blade and 7 years rotors have very low power coefficient and tip speed ratio, while the propeller and Darius type rotors, so here the propeller and Darius type rotors have high tip speed ratio going from 3 to 7 and also high power coefficient. So as tip speed ratio increases, the number of blades decreases. So if you want to increase the tip speed ratio, the blade should be decreased. So this is the graph of various rotors, uh, variation of power coefficient with tip speed ratio. Now next we will see variation of torque with tip speed ratio. So here on the x-axis we have again the tip speed ratio, that is velocity of outer blade tip to the free stream velocity, to the torque coefficient Ct. So here we can see that higher torque coefficient is observed in more number of blades, it is multi blade. So at lower tip speed ratio, while if you increases the tip speed ratio, the number of the torque coefficient is reduced, and if you increase the number of blades, that is four, sorry, if you reduce the number of blades, it is four bladed, three bladed, two bladed, the torque coefficient is reduced very much drastically. So it may be concluded that two blade propeller has potentially the best performance of the system, considered the two blade propeller rotate at a higher RPM with low torque. So these are preferred for electric power generation. The multi-blade types with high starting torque, on the other hand, are more suitable for pumping water. So this was the graph of tip speed ratio versus torque coefficient. So next we will see wind energy development in India. So this is a important topic, that where the development of wind energy has taken place, where there is potential, and where there is more need for development. So, the wind energy program in India was initiated towards the end of the sixth plan, that is 1983 to 84, that is end of the sixth plan. The market oriented strategy was adopted from inception, which has led to the successful commercial development of the technology. So, the broad based national program includes wind resources, assessment activities that we need to assess each and every part for the potential for wind energy development. Then research and development support. R&D is very much important, that where we need to invest more money so that our whole plan, all money depends on research and development to make it successful. Then implementation of demonstration projects to create awareness and opening of new sites. So we need to implement first, and we need to demonstrate to the whole nation that this wind energy plant can be successful and can generate energy, and also can give higher return on investment, it is ROI. So that is important very much, and we also need to involve industries so that development of infrastructure and capacity to manufacture the plants may be increased with the help of government's policy support. So this is the whole uh, development of wind energy, that how we can develop. So the wind resources assessment program is being implemented through the state nodal agencies. So that is C. There are two nodal agencies. So first one is a field research unit, FRU, of Indian Institute of Tropical Meteorology, and Center for Wind Energy Technology, that is CWET. There are two units, FRU and CWET. So this two unit helps in development of wind energy in India. So in India, wind energy program is managed and implemented by MNRE. So that is Ministry of New and Renewable Energy Sources. It is called MNRE. That is uh, that is an institute of Government of India. So the wind energy potential in India is around, as you can see, 49,130 megawatt as per estimates in the Atlas by Center for Wind Energy Technology, that is CWET. This estimate is done by CWET in their Atlas, Indian Wind Atlas 2010, that is a magazine, or that is published by CWET. So the potential is calculated with respect to 2% of land availability at windy locations, and pertains to a 50-meter hub height level of the wind turbine. So that is This is calculated on 2% of land availability and 50 meter of hub height. So on this basis, this potential is calculated. So now recently the total installed capacity is 17365 megawatt. Up to this is up to 2012. This data is up to 2012. So our India is the fifth largest producer of wind energy in the world after USA, Germany, Spain, and China. So various projects are still going in progress, which may increase the wind energy in India. So next, so the wind turbines, which are the main part of a WES system, are manufactured by around 18 manufacturers in the country with around 42 models, 42 different models ranging from 250 kilowatt to 2.5 megawatt, mainly through joint ventures or under licensed production agreements between government. So a few foreign companies also have set up their subsidiaries in India, while some companies are now manufacturing wind turbines without foreign collaboration. So the current annual production for 2012 capacity of domestic wind turbine is in the range of 3500 to 4000 megawatt. That is the current uh, it is the current capacity production in India. So as you can see in the diagram that uh, the potential is highest in Gujarat and the next is in Karnataka, and then it is similar in uh, the other four states, that is Maharashtra, Rajasthan, Tamil Nadu, and Andhra Pradesh. So the installed capacity is highest in it is highest in Tamil Nadu, then it is highest in Gujarat, and then it is in Maharashtra. So a very much increase is required in Gujarat where we are there. So wind energy development is very much required in Gujarat and also in Andhra Pradesh, because very little is being developed in Andhra Pradesh. So other states are having good amount of installed capacity. So this is the wind energy development in India, and this concludes our chapter of wind energy. So from the next lecture we will see other chapter uh, that is maybe ocean energy. So thank you very much, and this is the scenario of renewable energy sources in India, which we are discussing in renewable energy engineering subject. So we will discuss each and every renewable energy source. So thank you very much, and hope to see you in the next lecture.